We collect lots of data about the world we live in, but we do not have the capacity to turn all these raw numbers into information and into knowledge, because it is difficult to analyze and understand them as they are. How can we make sense of raw data? One way to understand data more easily is to represent it graphically, that means to visualize it. However, the complexity of today's datasets can be challenging. They may describe millions of entities, have many dimensions, and a high level of interconnectivity. An example of such complex datasets are data representing migrations of people between geographic locations. In order to help analysts understand large and complex datasets, new sophisticated tools and visualizations need to be developed. Visualization researchers at the University of Fribourg are working on solutions addressing the challenges coming from the complexity of migration data.
Flows of migrants have been analyzed for almost 2 centuries. For this kind of data, the most popular way of representing them is a flow map, which shows the numbers of people migrating between geographic locations with lines and varying their widths to show the number of people migrating. However, as the number of flows is growing, it becomes increasingly difficult to analyze this kind of data, especially when it comes to the analysis of the changes over time. Animation shows how the flow magnitudes change with simple transitions between the years. But it quickly becomes too difficult to follow all the changes which happen at the same time on the screen. In small multiples, we show several images on the screen at the same time, each representing one specific time period. The problem with this approach is that the more time periods we want to represent, the smaller images we have to use, and the more difficult it is to see the important details.
Another alternative to show the temporal changes is to use an abstract, non-geographic representation.
An abstract non-geographic view can give a good overview of the development in time, but with such a view it's difficult to answer questions related to the geography of the flows. For instance, how far they go, or which countries are neighbors.
Flowstrates, a different approach developed at the University of Fribourg, extends the idea of a flow map to support the analysis of temporal changes in migration flows.
We took the inspiration for this approach from strata, which are rock layers formed over time. You can see such layers in this picture of the Colorado Plateau. In Flowstrates, the origins and the destinations are shown in 2 separate maps, and the temporal changes of the flows are shown in a separate view in the middle. In this abstract view, the columns correspond to the years, and each row corresponds to a specific flow between a specific origin and destination, so we can see how this flow was changing over time.
Flowstrates embeds an abstract representation of temporal change into a flow map, which is a geographic representation. Being able to see the flow origins and destinations on a map is important for the observation of spatial patterns. By using an abstract temporal view, one can better visualize changes over time without the need of fitting the visualization into a map.
Flowstrates address the complexity of this specific kind of data, allowing to see both the geographic and temporal aspects of it at the same time. Because of its nature, the approach requires a lot of interaction from the analyst. Therefore, we continue to study how the interaction affects the analysis and how it can be improved.